Hi, good morning, and I'll make it quick. 2 years ago, for those of you that have been to Berlin, I had a short presentation on network programmability, and we also did some very short presentation of IoT-like devices with open source software and things like that. And in those 2 years, I haven't seen any frameworks come up or open source project that would actually enable IoT onboarding, so I built one myself. And the point of this presentation is actually to show you, if you have a well-defined frameworks and well-defined APIs, how easy it is to actually build a custom business rule-driven onboarding application. So, as IoT itself is still this, at least to me. So, no standardization, everybody has their own thing, or they don't have their own thing. People bringing mostly stuff from home, plugging into the Wi-Fi networks, and then you get things like the Mirai bot, you get denial of service attacks, compromised devices on your network, stealing your network credentials, running Bitcoin, or mining Bitcoin actually, and things like that. So using resources for not what they were actually built for. And IoT in itself is, to me, it's a framework. It's a framework of a bunch of things. So yes, you need an application that's actually going to show you something regarding what's going on. And it's usually something going on in the physical world. So to me, the IoT means it's a bridge between the digital and the physical. In the physical world, we have devices that are sensors or actuators. Doesn't matter what they do, they have some sort of contact with the physical world. They can measure, they can actually affect the physical world. If you're a sci-fi fan, read Philip K. Dick's novel, Ubik. It's all about IoT. And so they affect and measure the physical world in different ways. Then we need to get that information somehow through a communications channel somewhere. It could be a server, it could be somewhere in the cloud, it doesn't matter, it could be on your phone. The point is we need to carry that data in a digitalized form somewhere, process it, store it, and then display it to the user, because we usually are consumers. Or sometimes you have to carry the data to another device. That's called machine-to-machine communication. So still you take the data, you format it in a well-known format like JSON or XML or whatever. You carry it through the communication channel somewhere else, and that other device or other system processes it, stores it, and so on and so forward. So this is the framework. And then for us that are controlling these frameworks, we need two other things. One is a management platform. So we need to somehow remain in control of all of that. So maybe at some point this is going to be an AI doing that. But for now, we want to be in control. So we need a management system. And because of all the things happening today, this needs to be secure. So we need a security framework as well. So we don't want our data to be tampered with. If this is a Geiger sensor in a nuclear plant, you don't want false data. Or you don't want data coming in too late. Radiation is coming up. Oh, we just found out. It started happening 5 hours ago. You want reliability and you want it to be secure and not tampered with. So you want data integrity and all that stuff. Now, I come from a networking company. I'm also a networking guy with some software development background. And I'm obviously not going to create a whole new IoT framework by myself unless I start a startup. So what you end up doing is you have two pillars. You have this IoT framework that we just saw, and then you have your existing network infrastructure with whatever's there. And you need to create a bridge between the two. Yeah? So obviously we as Wi-Fi vendors, or network vendors, we're not vertical experts. We're not the experts in hospitality, we're not experts in nuclear plants, we're not experts in how you create a car, but we can create networking equipment and make the networks work. So you need to somehow to create a bridge between these potential verticals that use IoT and IoT frameworks and the network. And that bridge is normally a well-defined API and somebody that's able to consume it and actually make something from it. So what you need to implement? Business rules. So, okay, when you get a device on the network, when and how does it get in the network and what kind of priority does it get? I mean, if it's a Geiger sensor in a nuclear plant, it's not going to go into best effort, or maybe even into scavenger traffic, and you're going to start throwing it away. It needs to be highly adaptable because different verticals, different companies have different business rules. And the API and the data that you're carrying needs to be able to conform to all those different rules. So it must be very general and at the same time easy to consume. We're still lacking standardization. Yes, we have standards-based APIs like REST-based, and we have standards-based data formats like JSON, but that's about it. There's no business practices and workflows and things like that that are telling us how should you onboard, connect, and then carry IoT data. We don't have any of that yet. And security sort of works if you keep being in an enterprise environment, but as soon as you start connecting stuff from the outside, from the consumer world, or you want to interconnect a consumer-based environment with an enterprise environment, things get messy. So remember the security cameras with the Mirai bot? Yeah, that's that example. So carrying a consumer-grade product, because it's cheap, affordable, and easy to plug in, into the network, bringing down the global infrastructure, which is more and more interconnected. So the internet is not a bunch of isolated islands anymore. Everything is interconnected. Yeah? So this IoT ecosystem suddenly becomes anywhere, anytime, at any point in the network. So additional challenges of IoT. So who's going to connect them? Are you going to have a guy going around driving with a truck and connecting the IoT devices, connecting a static pre-shared key, or are they going to manage digital certificates? Or how are you going to enforce security rules, network access control? How do you classify that the device is compromised or not, and things like that? And once you do that for one device, how do you scale to thousands and millions of devices? Where are they? Are they still where they need to be, or did somebody take them and put them somewhere else? And finally, something that we saw this morning, how do you troubleshoot millions and millions of devices doing this? So these are the sort of challenges IoT brings. So I try to address a very small portion of it with my demo. So what I built is basically the bridge between IoT, all open source based, and what we at Aerohive call the Aerohive Cloud Services Platform with well-defined APIs. And I used two tools. So I took an orchestration tool, completely open source, which is either Puppet, or you can build it using Ansible, if you're familiar with that. One is agentless, the other one needs an agent. And I basically, at the end of the day, reinvented 802.1x without certificates. But the point is, this was really simple to do. It took me like a day or two to set up the orchestration server, which I didn't experience before, and to write a very small client-side application that would actually consume the APIs and get itself onboarded in a secure way. So the communication flow, if you're familiar with .1x, that's exactly what it is, but it does need certificates. And I was able to build this on basically any standards-based Unix client. If you have WPA2 supplicant or WPA supplicant, it's trivial. If you're using Android, it's trivial as well, because Android has a very strong API, so building something like this is, again, trivial. If you use Puppet, it has an agent, so it's agent-based onboarding. Again, very simple to use. The problem with agent-based is, however, they are pretty heavyweight. So running Ruby and the whole Ruby stack on a small IoT device can be a problem. But building something like this, if you have the APIs, if you have the operating system, if you have operating system access, is quite trivial. So I'll publish the source for this on GitHub. So with the presentation, you're going to get open source code for your Odroid devices, which can be actually onboarded the same way to the Aerohive access points in the ecosystem, or you can just use an open source tool like Puppet. So that's actually everything from me, and I think I am on time, and you can go to lunch.